Hi everyone, this is Shivam. Welcome to the sixth video of the series Kubernetes for Beginners. So far we have learned how Kubernetes keep your application alive, deployments, restart crashed pods, they scale when traffic increases. But now let me show you a different kind of problem. Your app is running perfectly, pods are stable and no crashes. And still, your application is broken. Why? Because of hard-coded configurations. In this video, we will understand why hard coding breaks Kubernetes apps and how config maps and secrets fix this issue. Let's talk about something very common. Inside your application code, you often hard code things like database URLs, usernames, password, API keys, and environment specific values. For example, local host in dev, production database in prod, etc. etc. This works fine at the beginning, but the moment you deploy your app across multiple environments, things get messy. You end up rebuilding the images for small config changes. For example, if just the database URL changes, you have to rebuild the application, create a new Docker image, push it to the image registry, pull the new image into the pod, and then restart your application, all for a simple config change. In Kubernetes, this is a big problem because Kubernetes wants your container to be reusable, portable, and environment agnostic. This means code and configuration must be separate. However, Kubernetes solves this cleanly. Instead of hard coding values inside your app, configuration goes outside the container. The same image runs everywhere. Kubernetes injects config at runtime, and Kubernetes gives us two tools for this: config maps for non-sensitive data and secrets for sensitive data. Let's understand them one by one. A config map is used to store non-sensitive configurations. Things like app environment, for example, dev, staging, UAT, prod, service URLs, feature flag, custom settings. Think of config map as external configuration that Kubernetes can inject into your app. Your container doesn't care where the values come from. It just reads environment variables or files. This keeps your image clean and usable. For example, if your database URL changes, you don't need to rebuild your application or create a new Docker image out of it and push it to image registry. You just have to update the config map and your pod will pull the latest configuration. Now you might be wondering, what is a secret? So secret solves a similar problem but for sensitive data. Things like passwords, tokens, API keys, database credentials. You never want these values to be hard-coded, committed to GitHub, or baked into the Docker images. Secrets allow Kubernetes to store and inject data securely. By default, Kubernetes stores secret value in base 64 encoded format and not in plain text format like config maps. However, base 64 encoding does not mean encryption. Out of the box, Kubernetes does not automatically encrypt secret at rest. In real-world setups, secrets are usually encrypted using cloud provider features or external tools which make them secure for production use. From your application's point of view, it looks exactly like a normal environment variable, but under the hood, Kubernetes treats them differently. Now the obvious question here is how applications actually use config maps and secrets. And here is the important part. Your application does not talk directly to config maps or secrets. Instead, Kubernetes injects them into the pod, either as environment variables or files. Your app just reads them. So the flow looks like config map slash secret to pod, container, and application. Same image, different configs, no rebuild. This is how Kubernetes app stay clean and production ready. Now that we have understood this conceptually, let's head on to the demo section and we'll see how we can create config map and secrets. So I am now in my Kubernetes cluster and I can see that I have one deployment which I created for my last video. Let's go ahead and create our first config map. So here I'm using imperative command to create a config map. The name of the config map is app_config and I am defining two environment variables here. One is app_env equal to production and another one is app_env equal to my name. Notice something important here, that I'm creating a config map with simple non-sensitive configuration values. So let's go ahead and create this config map. We can see that our config map is now created. Now similarly, let's create a secret. I'm again using imperative command here. So the name of the secret is app secret, and I'm defining two values in it. One is db user equal to admin, and another one is db password, which is secret123. Note here is that this information is sensitive. So instead of creating a config map, it goes into a secret. So let's go ahead and create the secret. Our secret got created. Let's check it. So here is our secret. Now let's go ahead and verify our secret on config map. So this is our config map, and we can see we defined two variables here. One was app env equal to production, and another one was app name equal to my app. Similarly, let's go ahead and verify our secret. Notice how Kubernetes clearly separates configuration and secrets. Config maps are readable, while secrets are stored in base64 encoded format. Now let's go ahead and create a pod so that we can use both our secret and config map. I have already written the configuration of the pod. Let me copy that and we'll go over it one by one. So as we can see here, the kind is pod. The name of the pod is demo pod. It is running an injects image. So this is how we are referencing our config map here. So it says env, and this is the name of the environment variable, whatever we defined in our config map. And it is trying to pull the value from the config map. So it says value from config map key reference, and we give the name of the config map here. So this is the config map which we created, which is app config, and the key is app env. Similarly, we are pulling the value from our secret. It says value from secret key reference. This is the name of our secret, and this is the key whatever we defined in our secret. Again, you don't have to memorize the YAML configuration for this. It is easily available on the Kubernetes official website. Let me show you how you can find this. So this is a documentation page where you can find about config map. Let me search for this config. And if you scroll down somewhere, you will be able to find, okay, here it is. So we can see here it is trying to reference the config map using config map key reference. Again, you don't have to memorize this structure. It is easily available on the Kubernetes website. Now let's go ahead and apply our file. So our pod got created. Let's check it. So it is saying our pod is up and running now. Here I'm injecting values from both the config map and the secret into the pod as an environment variable. So let's go ahead and verify those environment variables inside the pod. So we'll do an exec into the pod using kubectl exec -it, which is interactive terminal, and we'll put the name of our pod and we'll output the environment variables. So we can see here, these are the two variables which we specified. So we have app name equal to, app environment equal to production, and this is the database password. So from the application point of view, these looks like normal environment variables. The application doesn't know where it comes from. Just to be precise, config map removes the need to rebuild Docker images. Whether a pod picks up updates automatically depends on how the config map is injected. When config maps are injected as environment variables, the pod needs a restart. When they are mounted as files, Kubernetes updates them automatically. So let's try to update our config map here and we'll see this in action. So remember here, I changed the environment variable to staging, which was earlier production here. Let's exec into our pod. And we can see here that even though we made changes to the environment variable, our pod is still showing that app env is equal to production and it has not been updated. So this clearly backs my statement, which says when config maps are injected as environment variables, the pod needs a restart. Again, to pick up this change, I would need to restart the pod, but still I don't need to rebuild the image. In real production setups, pods are usually created using deployments. So when a pod is deleted, Kubernetes automatically creates a new one with the updated configuration. We covered this in the previous video where Kubernetes always works to match the desired state with the actual state. So we will delete this pod and we'll reapply our pod again. So our pod is deleted. Let's check it once. Now let's recreate our pod. It says pod created. Now let's do an exec into our pod. You see it, the environment variable is now staging instead of the production. This happens because we restarted our pod and pod pulled the latest configuration from our config map. So the key takeaway here is Kubernetes injects configuration at runtime, keep images clean, and separate code from configuration. Now we have solved configuration. Our application is running using deployments, scales when traffic increases, reads configs from config maps, keeps secrets secure, but there is still one big gap. Right now, everything we have built lives inside a Kubernetes cluster. Users on the internet don't know pod IPs, service name, and node ports. They just type the URL in the browser. So the next question is simple, but very important. How does the traffic from the internet reach your Kubernetes cluster? This is what exactly we will understand in our next video. See you in the next one. Till then, keep learning.